So let's get started while kids are joining. So in yesterday's class we talked about, or we did a recap of all the standard formulas that we need to be aware of for calculating volume and surface area, and all those formulas that I told you guys, I forgot them all. I do that on purpose. Hey Sriyan, hey Jana. So basically whatever formulas I talked about yesterday, I forgot them all. And what I mean by that is, even if you guys have also forgotten or something is very faded in your memories, don't worry about it. When we come to the problem, when we try solving it, we'll try to see how much we can recall and what is the easiest way to solve those problems. So today's class will be primarily around how do we apply our understanding of all the 3D objects that we talked about in the previous classes, and then how do we put those concepts together for solving these problems. Okay. So today's class is going to be more like a class for me to relax. I'll take a couple of big fat naps in between when I'll ask you guys to do problems. Okay, I mean I cannot fall asleep that easily, but yeah, we will do a lot of problems is what I'm trying to say. Alright, hey Viswa. So let's do a quick roll call and then see who all we have. So we have Nikhil, we have Davik, Jenna, Neil, Sarah, Praneeth, Ritika, Saranya, Shriyan, Vishal and Viswa. Some kids are still missing, and that is understood because it's a festival time. So let's get started with the problem that we want to solve today. So I will flash the first problem on the screen and then I'll disappear while you are solving the problem. I'll just go grab my charger. Okay, my phone is running low on battery. So let me start with the first problem. And these are the problems that I had shared yesterday, but we will try solving them today. So the first question, okay, I'm reading it and we had read this question and we tried, I kind of blabbered through that problem and I thought that okay, everybody has understood. We will see who all has understood it and who are able to solve it without any problem. Okay. So I'm reading the question once. Water is poured into a rectangular container. Rectangular container. Water is poured into a rectangular container. There is a container which is of rectangular shape. 10 centimeters long. So if this is the length, this is 10 centimeter. 12 centimeter wide and 9 centimeter high. Okay, so now we cannot fill water in a rectangle. It has to be a three-dimensional object. So now this probably makes a little more sense. So this container is 10 centimeters long, 12 centimeters wide. So this is 12 centimeters from here to here. This is the width. And 9 centimeter high. So from here to here, this height is 9 centimeter. Until it is 1/20th full. Okay. So water is poured into a rectangular container which is 10 centimeter long, 12 centimeter wide and 9 centimeter high until it is 1/20th full. Okay. Somebody joined. Let me just check. Who is that? Oh, it's Ananya. Okay. So in today's class, as I was saying, Ananya, we are only going to do problems. No teaching, only practice. That's what we'll do. Okay.
Okay.
So first problem is water is poured into a rectangular container 10 centimeter long, 12 centimeter wide and 9 centimeter high until it is 1/20th full. All the water then poured into an empty cylindrical container. You fill till 1/20th is full and then this water is poured into a cylindrical container, empty cylindrical container with a circular base of radius 3 centimeter. It has radius equal to 3 centimeter. The height of the water, so depending on how much water it was here, you poured that water, and the water is, height of the water in the cylindrical container is y over pi centimeter, where y is the constant. What is the value of y? So I'm just repeating the question one last time. This is a container, rectangular container, or basically a cuboid shaped container, which has length 10 centimeter, width 12 centimeter, and height 9 centimeter. And you guys all know how to calculate the volume of a cuboid. It says water is filled till 1/20th, meaning 1/20th of its volume. Now this water is poured into a cylindrical container which has a radius of 3 centimeter. Obviously, all the water is emptied into this container. It will fill up some height depending on how much volume of water was there, and it fills it till y over pi height. Hello, Emily.
Hello, sorry I was late.
No worries, Beta. It's okay. So we are starting with the first problem, and this problem we talked about briefly in the class yesterday. So I'm just repeating that problem one more time. I want you guys to solve it. This is a rectangular container with dimension 10, 12 and 9 centimeter. 10 centimeter long, 12 centimeter wide and 9 centimeter tall, till 1/20th of the volume. And now this whole volume is emptied into this container, which is cylindrical in shape with a radius of 3 centimeter, and water goes up to a height of y over pi. And you all know pi is nothing but is another constant which equals 22/7 or 3.14, whatever you remember. So we have been asked to find out the value of y. Yes, Praneeth.
6.
6. That was super quick. I think I wasted a lot of time reading this question. So let's see what Davik says.
I also got 6.
You also got 6. I will give 2-3 minutes to everybody else. Ritika, Neil, Sarah, Emily, Ananya, Saranya, Jana, everybody to give it a shot. And then Sriyan, Vishal, everybody. Okay? And Vishwa too. So you guys have 2-3 minutes, and that's exactly the amount of time I have to go and grab a charger from my phone. Okay? I'll be back. Okay, Yananya, what is that you got?
I got 6.
You also got 6. 6 as in 6? What is the unit? I'm sorry, beta?
I got 6.
6 as in 6 what?
6, 7?
6 centimeters? Yeah.
Yeah.
That's the unit for all the other dimensions that you see here. So yeah, it'll be 6 centimeters. I know that was not a very intelligent question. I was just trying to make sure that we are not overlooking the dimension part of it. Okay. Neil, Sarah, what's happening? Ritika, I'm sorry, beta?
Still solving it.
Still solving it? Okay. How about Ritika? Solving it? Okay. Saranya, Nikhil?
I'm still solving it.
Okay. I hope I'm not bugging you guys much, okay? I'm just checking if all the kids are comfortable giving it a try, or there's something that is bothering them? Okay. How about Emily?
Still solving it.
Oh, okay. Vishwan, Vishal? Yes.
Question.
Yes, beta?
Wait, like, what's the last part? Like, what are we supposed to solve for?
Why?
Okay.
So again, I'm repeating. This is the cuboid you have, and here are the dimensions. And then what is filled till 1/20th, meaning 1/20th of the volume. And then this whole water that was in this container before, that gets emptied into this rectangular cylinder, which has a radius of 3 centimeters. And the question says it fills water up to y over pi centimeters. So we have been asked to find out what is the value of y.
Okay, thank you.
Biswa, Sriyan, what's cooking up?
I'm still solving it.
Okay. I'll give you guys 2 more minutes because this is the carryover problem from yesterday's class. We have more interesting problems to deal with. And as I told in the beginning, I'll take a nap when you guys are solving the problem. So more the time you take, more fat my nap would be. I'll just give you guys probably 2 more minutes, okay? 3:16 is when I'll jump onto it. What's happening, Jinnah? Working on it?
Yes.
Okay. Okay, I woke up. So, can somebody tell me, somebody who was working on it, probably it could be Saranya, Ritika, Emily, Sriyan, anybody, tell me what you were doing so far. I mean, basically, now if you just give me the approach that you were following, I'll complete the rest of the calculation. And it's okay. Just tell me what approach you were considering, so that way it becomes easy for me to just do the calculation without wondering or thinking about the plan. Nobody wants to share. Guys, you guys have to be very, very comfortable sharing your point of view, okay? Because teachers are not supposed to be any scary creature. Okay, alright, so let me, I know Praneeth, Davik, Nanya, and I think one more child has given me 6. Okay, so let me solve it and you guys can verify if your approach was same as mine. So when I'm solving this like a student, this is a container. What is the problem saying? There's a rectangular container. There's nothing called rectangular container. It will turn out to be a cuboid, meaning every side is like a rectangle. And this is the dimension given: 10, 20, 12 and 9 centimeters. So 10 centimeter length, 12 centimeter width and 9 centimeter height. Okay? Emily, Sarah, Neil, everybody, just be with me, okay? If I'm going fast, stop me. So these are the dimensions given. And it says that the water is filled till 1/20th, meaning 1/20th of its volume. That's the only thing I can make out by the statement. Let me just read it. So let me just read it one more time, just to make sure I'm not making a wrong judgment here. And it says water is filled until it is 1/20th full. So it's saying it's 1/20th of the volume. So let's find out how much is the volume of this guy. So volume of a cuboid is a symmetric shape. So find out the volume of the base, multiply with the height. Volume of base 10 into 12, length into width, times the height. So 10 into 12 into height. It says it is 1/20th full. So if this is my total volume, it is 1/20th full. Right? If somebody says half full, I'll multiply it by half. It says 1/20th full, so I multiply it by this. So this is the amount of water we have in this container. Everybody agrees? Yeah. Now, this is the amount of water we have in this container. Now this whole water is poured into this. So basically, this amount of water goes from here to here. And let's see how much it will fill. It already tells us, okay, what is the dimension of this cylinder? How much is the height? What is the height of the water also? That also it's telling us. Now, for this cylinder, right cylinder, what will be the volume? Again, it's a symmetric shape. So we'll find out the area of the base, multiply that with the height. Again, height is height as in till the water is filled. So what is the area of the base? Pi into r square. R is 3. Pi r square into height. What is the height given? Meaning after the water is poured, it will fill up to the volume. It will fill up to a height such that the volume of this water is same as the volume of this water. So this water and this volume that goes in here will be the same, assuming there is no leakage. Okay. So pi r square is my base and times the height. Height is given as y over pi. Okay, wonderful. Now let's do some calculation here. 10. Okay, and you guys would have seen me playing with numbers. So that's what we'll do here. So this part is 10 into 12 into 9 into 1 over 20. This is what this part is. Now what I can do is, let's try breaking the numbers. This 20 I can write as 10 into 2. Okay. And this 12 I can write as 6 into 2. I'm just factorizing them, okay? So that I can play. This 10 and this 10 I can do tic-tac-toe. This 2 and this 2 I can do tic-tac-toe. And for kids like Emily who doesn't know what is tic-tac-toe, this is the playful part of the math that we do. And when we do calculation, see, you always have the option of multiplying all these numbers and dividing by this. But then in a scenario like this, I always prescribe you guys to make the number smaller, simpler, get to the most simplified form so that you're dealing with easier calculation rather than grappling with big numbers to calculate. Okay. So that's what we did. So we had 10, we kept 10 as 10 because we saw 20 here, which is nothing but 10 into 2. And we tried factorizing this also, 12 into as 6 into 2. So now this 10 and this 10 we can knock it off. There's no point multiplying by a number and then dividing by the same number. That's what is the purpose of this tic-tac-toe. Similarly 2 and 2 we could knock off. So this became 6 into 9, 54. So this 54 is nothing but 54 centimeter square, right? So this is 10 into 12 centimeter, and this 9 is also centimeter. Okay, so this is centimeter cube equals this whole thing. Now here, you straight away saw pi and pi. You can do a tic-tac-toe, no point multiplying by pi and then dividing by pi. Now you have y into 3 square. 3 square is nothing but 3 into 3, that is 9. So, this many centimeter cube, centimeter square, y, okay, yeah, centimeter cube. So basically, y equals, I'll get the 9 here and centimeter cube here. So 54, it goes like this, right? So this y, 9 will come down and then centimeter cube by centimeter square. Here you have pi r square, 3 centimeter square. We don't know what is the value of, we are just given it's y by pi. So we'll find it out. So here this became 54 by 9, that is 6. 6 9s are 54. And this is centimeter cube, so that is centimeter into centimeter into centimeter. And you guys must be thinking that what is this old man doing? I'm just trying to make sure that we don't ignore the dimension part of it. This centimeter also can do tic-tac-toe. 1 centimeter here, 1 centimeter here also can do tic-tac-toe. I'm left with 6 centimeters. So that's why, if you guys remember, I was insisting on what is the dimension. Okay? Because 6 centimeter versus 6 mile, there's a huge difference. So you want to be careful about it. But whatever I did, that should have been a very straightforward thing for you to follow, you guys to follow. If I at all got anybody confused or I made it complicated, let me know. I'm not asking you guys to put me on the spot. You're just asking for help. If I did not explain it well, I can do it one more time. That's what I mean. Emily, Saranya, Neil, Sarah, Jana, everybody clear? Ritika, clear?
Yes, sir.
Okay, okay. Now, we have spent 20 minutes on one problem and it's okay. It's not about rushing and doing something. Ultimately, it boils down to, are we getting the approach? How successful you would be is not a function of how many problems exactly we are solving in the class. It's about for how many types of approach that you guys are able to follow or use so that you can multiply that with the number of problems that you want to solve. Okay? So as far as you are clear with the approach part, we are doing okay. Is everybody okay so far? Shall we move on to the next one? Okay. Let's look at the next problem. And again, you guys have to bear with my drawing skills, which is amazingly horrible. See, kids who have better drawing skill would probably choose to laugh at me, but that's okay. Okay, this is, okay, let me read it so that so there are two things. This is just a picture that drawn. It says here to here, this is H, and here to here, which is more like a diameter of the circle that you are seeing in the center, is D. Now let me read the question for you guys. A top is formed by focusing two identical right circular cones. A top is formed by fusing two identical right circular cones by their base as shown. So now if you try visualizing what I had drawn, it's like two cones put on the top of each other by their base facing towards each other, and that forms a top. The height of the top, meaning which is getting created by fusing these two cones, right circular cones, is h. That's what I was saying. This whole height is h, which is the distance between the two cone points in 6 centimeters. The height of the top h, which is the distance between the two cone points, is 6 centimeters. Okay. The diameter of the circular cone base, D is also 6 centimeters. So you are given that H is equal to 6 centimeter, D is also given as 6 centimeter. Okay. What is the volume of the entire object in cubic centimeters? So all the chartering I was doing so far, summary of that is you have two right circular cones placed on the top of each other by their base facing each other, and that forms this top. And the height of this top is from here to here, which is coming from these two cones put together, is 6 centimeters, and diameter of the base is 6 centimeter again. We have been asked to find out the total volume of this top. Is everybody clear about the question? And one extra line I want to add in here is this top is creating by fusing two identical cones, right circular cones, okay? So these are identical, okay? So whatever is this volume and whatever is this volume, they are also same. These are identical cones, okay?
Sir, can you repeat the question one more time?
Okay, sure. So you can see the picture, right?
Yeah.
Okay. The question says a top is formed by fusing two identical right circular cones by their bases as shown. Two right circular cones. We all know with my amazing drawing skills, this is how a cone would look like. Yeah? I mean, obviously this is not looking like a cone. Better version of the cone, yeah. So this top is formed by fusing two identical right circular cones by their base. The height of the top, which is the distance between the two cone points, is h, which is equal to 6 centimeter, and the diameter of the base is also 6 centimeter. We have been asked to find out what is the volume of the entire object in cubic centimeters. And let me make your life a little easier. And these are the options given, okay? 9 pi, 18 pi, third option is 36 pi, and fourth option is 72 pi. Yes, Pranay?
9 pi.
9 pi, okay. Ritika? I'm sorry, beta?
I got B.
You got B? Okay, that's good. That is what is called unity diversity. Two different approaches. We'll come to that. Okay? Anybody else? Yes, Shreyan.
I got B.
You also got B?
Yeah.
Wonderful. Time for everybody else to introspect. Whoever got B, they are getting challenged by people who got A as an answer. And people who got A, they are getting challenged by the people who got B as an answer. Summary of that is verify your answer, review your answer, so that if there is something that you overlooked, Pranay.
For the height, is that the height from the top all the way to the bottom?
Yes, sir.
Okay.
Saranya, Emily, Jina, Neil, Sarah. Pranay.
So from like the point of the top cone all the way to the point of the bottom cone, that's H.
Yep.
And they're both congruent.
They are both congruent. I mean, it says identical, so that's how I would interpret. Yeah.
Okay.
Yeah, Neil.
What does the D equals centimeters thing say?
6 centimeters.
Okay.
So
And where's D? Where is D?
D is the diameter of the identical base.
Okay.
So basically, right circular cone you should see, right? The base is always a circle. So D is nothing but the diameter of that circle. Okay, what's happening? Anybody else? Praneeth, did your answer change or you are sticking with A?
Sticking with A.
Okay. Okay, Jenna,
I got B.
you also got B? Wonderful. So we have Ananya. I'm sorry, Vita?
B.
B. Okay. Nikhil.
I got B.
You also got B. Davik.
I got B.
Okay. Alright. And see how firm Praneeth is standing against all of you. Again, no, nothing against Praneeth, nothing against any of you. What I'm liking here is, be it right or wrong, if you have found your answer by yourself, you'll be more convinced about that answer. Okay? Emily, Neil. Yeah, Emily, go ahead.
Wait, can you say the answers? I can't really see them.
Okay, one answer is, first option is 9 pi. Second one is 18 pi. Third is 36 pi. And fourth one is 72 pi.
Okay, thank you.
Okay. Anybody else? Saranya, what you are leaning towards? Vishwa, Vishal, Vivan is also here.
Wait, we're supposed to find the whole thing or one of the pyramids?
No, it says find out the volume of the top, which is created by fusing the two right circular right circular cones.
So it would be the whole thing.
Yeah, it will be the whole thing.
Then it's B.
It's
I
B.
got confused because when you said top, I thought just the top of the shape.
No, so it says top is created by fusing the two identical circular cones. So that, okay, Neil.
Yeah, I got B too.
Yeah. So see, now Praneeth had a point. He was very clear that okay, if I have understood the question correctly, if it is only this much, no matter how many people are saying B, I'll stick with A. But then he got to realize that okay, we are talking about the entire thing. So he was not wrong with his approach. So that's where it's very important for us to to be very firm with our solution. Okay, if 50 people start shouting, okay, answer is C, that doesn't mean I'll change my answer. Okay? Okay, so let's come back to this one. Now let me try solving it so that you guys can also verify your answer. Okay? Now the question says this is the height, meaning, and this height is of the top, which is created by fusing two identical circular cone. We know that volume of a circular cone. So okay, these are identical. That means from here till the first cone's height is 3 centimeter, and from here to here it is 3 centimeter. They are identical. And the diameter is given as 6 centimeter. That means the radius will be half of 6. That is 3 centimeter. Now, if you all remember, volume of a cone, volume for a cylindrical cone is nothing but volume of a right cylinder, which is pi r square h divided by 3. Be it a circular cone or be it a rectangular pyramid. Whatever is the volume of the parent's shape, if I am talking about rectangular pyramid, rectangular prism, it's a child of a cuboid. I'll find out the volume of the cuboid, divide that by 3. If I'm talking about a circular cone, the parent of that is the cylinder. I'll find out the volume of the cylinder, divide that by 3. So here, I'm trying to find out volume of one of it and then multiply by 2 because they are identical. So pi times r square. What is my radius? 3 centimeter. 3 square. So 3 into 3. Times h. Again, h of the cone. Okay, not the entire h. So I'm talking about 3. Divide that by 3. Do we have to do any calculation? We have to just play. this 3 and this 3 tic-tac-toe. Done. 3 into 3, 9 into pi. This is what I got. But this is my volume for one cone. And this one also has to be added, which will be same as this one. So 9 pi plus 9 pi. That is how it adds up to become 18 pi. So everybody got the right answer. There's nothing that I taught you guys. I just reconfirm because of the problem that I deal with. My problem is I don't trust anybody. I know I keep talking about it very often, but the idea is, yeah, you guys also should do your calculation to be 100% sure about what we are doing. But did everybody follow what I said, or did I do the same way like you all were doing? Yeah? Everybody, Viswa, Vivan, okay? I know Vivan joined a little late, but are you guys able to follow me so far? Viswa and Vivan has not spoken yet. I'm just trying to make sure that they are with me.
Yeah.
Yeah? Okay. Vivan, are you clear, beta? Okay. All right. So sometimes magic do happen. Even if I try my best to get you guys confused, I'm still not able to do it successfully. Let me make one more attempt. Okay. Let's see. What is the next problem that we want to solve? Now this is a loaded. This is looking like a loaded question. Okay. I mean, if I look at it like a student, I just read the question. See how much words this question has. Let me read through it. The question is the pyramid at Khufu. I don't know if I'm saying the name correctly. The pyramid at Khufu is one of the great pyramids of Giza. The right pyramid, mark the words, the right pyramid has a square base with base length of 230 meters. I'll not make an attempt to draw this picture, okay? I'll go by what we have as a definition here and then leave it for your drawing skills. The pyramid of Khufu is one of the great pyramids of Giza. The right pyramid has a square base with base length of 230 meters. The original vertical height of the pyramid is believed to have been approximately 146.5 meters. So let me write the number so that you don't have to memorize it all. The right pyramid has a square base. So it's a right pyramid with a square base. Has lengths of 230 meters. The original vertical height of the pyramid is believed to have been approximately 146.5 meters. Due to erosion, the height is now approximately 139 meters. So original height of this pyramid was 146.5 meters. Due to erosion, the height has reduced to 139 meters. If the base area of the pyramid did not change, what is the difference between the volume of the pyramid now and the original volume of the pyramid in cubic meters? A loaded question, but not enough weight, I would say, because if you guys know what do you mean by rectangular prism, then it's just about dealing with this. So I'll read the question one last time and then I'll leave you guys to grapple with this. The pyramid of Khufu is one of the great pyramids of Giza. The right pyramid has a square base with base lengths of 230 meters. The original vertical height of the pyramid is believed to have been approximately 146.5 meters. Original height of that was 146.5 meters. Due to erosion, the height is now approximately 139 meters. So this was the original height, this is the new height. if the base area of the pyramid did not change, so there was erosion that kept on happening, so height kept on reducing and reduced from this to this, but the base area has not changed. It says what is the difference between the volume of the pyramid now and the original volume of the pyramid in cubic meters. So after this height there is some volume, after this height there was some volume. What is the difference in volume? Now these are the options given, okay? I'm trying to see if you guys have some smart way to minimize your effort. Let me put down the options. The options given are option A is 575 meter cube. Option B is 132 250 meter cube. Option C is 2,451,033 meter cube. And option D is 2,583,283 meter cube. Yep, right. B. Okay. So, for all the kids who are trying to catch up on this verbose question, it says it's a rectangular pyramid with a square base. So this is the length, this is the same length, and this was the height before. This is the new height after erosion. So it says what is the difference in volume? Earlier there was some volume, there is some new volume. How do you find out the difference in volumes? And Praneeth was very quick in giving the answer. I will try to learn some tricks from him to understand how did he get to that answer very quickly. Okay? But let everybody give it a try first. Everybody heard the question, right? Ananya, Ritika, Nikhil, Sarah, Neil, Emily, Praneeth. Praneeth has already answered it. Okay. Davik, Jenna, and Shriyad as well. And I did not call out some name, don't worry, I'm not ignoring anybody. I'm just assuming that most of you have heard the question and giving it a try. We have 2 more minutes, or maybe 2-3 minutes, okay? Only dirty technique that I want to teach you guys, and this is probably, you have not heard this term from me before. Dirty technique is, sometimes you guys have to find out ways to solve a problem without solving it also. That is when you think backward, okay? So it's not about always going through the longest process or steps to solve the problem. Sometimes, in the interest of getting a better score in SAT, you have to identify some problems which you can solve without solving it actually, okay? So that's what we keep focusing on as well, along with learning the concepts, okay? So I'll disappear for 2 minutes. I'll let you guys try. Yes, Ritika. Little louder, beta. B. Okay, wonderful. Let's see. So you are not alone. You have a companion. Praneeth also got B. Ritika also got B. Let's see who all are giving company to these 2 kids, or they have a different path to follow. Yes, David.
I also got B.
You guys are becoming good friends. Okay. Where is Nikhil going? Nikhil, I see some background video, which looks great. Yes, Riya.
I'm trying to turn my brother's background thing. It's not letting me. I tried to switch around and go, but I don't know what he did.
I'm very used to seeing it when you can join us.
Yeah.
Yes, Riya.
I got B.
You also got B. All are becoming good friends. Let's see.
Sir, I have a question.
Yes, beta.
So what are you supposed to solve for? What's the last part of the question?
So the question says that you had a rectangular pyramid, a rectangular prism, whatever you call it, I mean, you had a pyramid which is in the form of a rectangular prism actually, okay, which has a square base. So instead of rectangle, it's a square. Earlier this was the height. So when you look at a shape, it has some volume, right? Due to erosion, the height reduced from this to this. So the question says, find out what was the volume before erosion and what is the volume after erosion and what is the difference between the two.
Okay.
Yeah, Jenna.
I got B.
You also got B. See, you guys have started thinking on the same lines. Be it right or wrong, we'll figure it out. Mandeep, you are joining 11 minutes early. You'll have to solve a problem relating to volume of 3D objects. You can join after 10 minutes, okay? You're early for the class. Yes, Nikhil.
Sir, I got B.
You also got B? Okay. Okay, so let me okay. Emily, Biswa, Vivan, what about you guys?
I'm still solving.
Still solving? Okay, so today I have some mischievous plan. I want to learn from you guys. So now, let's see, before I could finish all my answers, before I could finish writing all the options here, Pranit came back and said B, and everybody is leaning towards that. So Pranit, can you teach us how did you get to the answer option B so quickly? What was the technique that you followed?
So, you said to find a difference. So I used the rectangular prism volume thing where you just 1/3 of the rectangular thing. And I used a calculator for most of this. So like, because like 230 squared is like not something I could do that fast now. So I used a calculator for this. And then using that, I was able to subtract the two things and got to B.
Okay. Did anybody use a different technique? Yeah, Nikhil.
Well, I was like solving the 146.5 meters, like I was like doing that, like the first original height. And then I realized that the option B was the 146 thing. So then I looked at option C and I realized the difference between the both was option B. So that'll be the right answer.
Okay. Anybody else has a better story? Or different story rather? There is no better solution. There is a different solution. Davik, Jenna, Sriyan, anybody? No? Okay, so now look at this. I have, like I was saying, right, we end up learning some, I use the term dirty techniques, but those are actually not dirty techniques. Those are some learning from what we practice, right? Now look at it. Before we try solving it, okay? Ultimately, the question is simple. It's a rectangular pyramid. This is the base and this is the height. Base is like a square. That's why only one dimension is given. So this is 230, this is 230. That part is okay. It says that due to erosion, only the height is changing. The base doesn't change. So basically, it's eroding along the slanted this thing. Let's not get into that. First of all, what is the formula for? We know that volume of a cuboid is base into height. What is the base? Here my base is, okay, base into height. So length into width into height. Here in case of pyramid, this becomes by 3. Okay. Now, other thing that we are seeing here is my length and width both are same. So this is length into length, or 230 into 230. I'm still not doing any calculation, okay? I'm just scribbling. And the height. From this one, with this height, I'll plug h here. With this height, I'll plug in place of h here. And we have to find out the difference. So imagine a situation like this. 146.5. This is the original pyramid, and this is the pyramid after erosion. But between these two pyramids, what you see, this 230 to 230 by 3 is something which is common in both the places. Do I want to multiply here, waste my time, and again do the same calculation, waste my time? No. I will just take it out. 230 into 230 by 3, this is common, I'll take it out. And then I'm left with 146.5 minus 139. So this is a one-time calculation for us. Now, 230 into 230, let it be, I will figure it out, by 3 into 146 minus 139. This would have been 7, it's 6.5. 39 plus 6, 145. Okay. Plus 7. 7.5. Correct? Now, here, there is one more thing that we can do. Okay. I'm not doing the whole calculation. I don't need a calculator for this. I converted this. This 10 and 10 I can knock it off. 3 is 325 times 75. Now I am here 230 into 23 into 25. This is the number. So here it's like 100, and this is, let's say this is 230, and 25 into 23 will be somewhere around 600. 25 to 25 is 625, let's say 600. So when I'm looking at this kind of a thing, I can get a 6-digit number at maths. I cannot get a million. So it's like 600 into, do some estimation, what that becomes. 6 into 2 is 12 and 4 zeros. Which is the closest number to this? This one. I don't need a calculator for this one. What I'm saying is, we don't have to match the exact value. What we have to do is find out. See, all these have huge difference. This is only 575 meter cube, and this is 2 million. This is 2.5 million. We are somewhere in the middle. I'll just go for this one. Yeah, because I did an approximation here, right? 23 to 25, I said 600, and then 230 I rounded to 200, and I was getting somewhere around this. This is the best I could get. This is the best possible option that we have. So we are, again, while explaining I took a little longer, but when you are doing the calculation, the way your brain will work is, okay, these two are common, so I'm only talking about the difference, 146 and 139. So this whole thing multiplied by 7.5. Okay? So 7.5 by 3, 2.5. You're multiplying this whole thing by 2.5. 200 into 200 gives you 400, and you're multiplying that by 2.5. That gives you somewhere close to this. So when you're doing all this calculation, when you are in the A part of land, this is when your brain is working. Say, okay, my base is not changing, so this minus this, the difference. So this into this whole thing, multiply the difference. Okay. You do some quick rounding and you'll say, okay, fine. This is what I'm going to. Yeah? This will help you solve some problems in a less time when you have this kind of situation. When you see a huge difference between your options, it'll be easy to eliminate. But I'm not saying that you don't have to calculate. Calculation is a must. That's the most important building block. But these are some tricks on the top of your knowledge or understanding of things for doing the problem faster or getting to the answer quickly. Yeah? Is that okay? Is everybody clear? No complaints, no concerns? So if that is the case, then I'll let you guys go. Enjoy the rest of your evening and wish you all a happy and safe Diwali.
Have a good day, sir. Have a
You
good
as
day.
well. Alright. Bye bye. Take care.
Yes, sir.
Bye bye. Bye bye.
Bye.
Bye bye.